Hi guys. Today and next time, so this whole week we're going to do lesson 6.4. So we're going to start with this linear factors, day one, and we're talking about partial fractions. So I'm on page 398, and I tried to take these examples from somewhere in your book. So hopefully you can kind of follow along and pause it when you need to and whatnot. If you look at this, what I wrote right here, you have f of x equals x plus 13 over x squared minus x minus 20. Now we know how to take this and add it together to get this. But what we're going to do today is we're going to start with this and end up with the partial fraction decomposition. So each fraction in the sum is a partial fraction. The sum of these partial fractions make up the partial fraction decomposition of the original rational function. That's a lot. That's a mouthful. Okay? So I'm just going to show you how they get this with this problem here. And then we'll do a couple practice problems. So what you want to do first is you want to get the denominators. And, oh my pen. If we factor this, x squared minus x minus 5, we're going to get our x minus 5 and our x plus 4. So that's what goes underneath as your denominator. So here's an x minus 5 and an x plus 4. Then we need to have the constants up here, which we don't know what they are. So we're going to label one A and the other one B. And then we're going to find out what A and B are. So let me insert some space here. So what we're going to do is we're going to write down just the numerator on the left side of this equal sign. And on the right side, we need to take a look at each partial fraction and determine what part of the denominator it's missing. So for instance, this a over x minus 5 is missing an x plus 4 in order to get an x minus 5, x plus 4. Okay? So to complete that, we'll have to multiply this a by the x plus 4. So I'm going to write that out. And then likewise, we just have a plus there. The b partial fraction, that's missing an x minus 5. So I'm going to write it out as b times x minus 5. Now I'm going to factor or distribute those through. So a times x plus 4a plus b times x minus 5b. So I just choop, 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 choop. There we go. Good sound effects, I know. And then what I'm going to do is I'm going to group them. So I have an ax and a bx. So those I'm going to pull out front. Ax plus bx. And I'm just rearranging right now. And then I have a 4a. Nothing really goes with that. And I have a negative 5b. Nothing really goes with that. So if I take this group right here, and I did this on purpose because I can factor out an x from that group, which I will do. And if I factor out an x, now I'm left with a plus b. Over here, there's nothing, that's a terrible b. Over here, there's nothing common. I can't factor anything out. So I'm just going to write it as 4a minus 5b. Okay? Since this is all just constants, okay? This one has the variable. So now we're going to compare this section and this section with what we should have been copying down the whole time. X plus 13, x plus 13. Okay, so this has to equal this. Let me switch colors again. And if you notice, this is your variable, this is your variable. This is your constant, this is your constant. So I'm going to set my variable equal. So it's 1 times x, and this is a plus b times x. Since they're equal, I know that a plus b have to equal 1. That's probably the trickiest part for kids to understand. Okay? And then I also know that the constant part has to equal 13. So I'm going to write 4a minus 5b equals 13. So I have 2 equations with 2 unknowns. Let me go back and explain where I got this first one again. Okay? So I have equal parts. I think it's easier to understand that this is the constant and this is just a constant. Okay? So we set those equal to each other. Up here, when we work with the variable x, what's multiplied to the x here is a plus b. What's multiplied to the x here is 1. So if we divided out those x's, we'd have a plus b equals 1. And that's what I have here. The next thing is to just solve. You have 2 unknowns and 2 equations, so you can solve this however you like. If you want to put them in matrices like we've been dealing with, go for it. I think I'm just going to multiply this top one by a negative 4 and then add them together. So I have negative 4a minus 4b equals negative 4. That I'll leave the same. 4a minus 5b equals 13. Add them together. That eliminates my a's. So I have a negative 9b equals 9, which means b equals negative 1. And since b equals negative 1, I can go back to my original equation or any of the equations I want, plug it in, and I should find that a is going to equal 2. We're almost done. We basically are done. So the last thing you have to do is just plug in your 2 for this a here and this negative 1 for this b here. So what you have, let me just do some fancy erasing. My a was 2, so I'll put a 2 here. My b was negative 1, so I'll put a negative 1 here. And if you take a look, that is the same thing that they got up there. Okay? If you went ahead and multiplied these through, you should get the expression that they had to begin with. So it's a lot of steps, but it goes faster, obviously, the more practice you have with it. So I will go through a couple more. So the first thing is to factor the denominator. So you know what your denominators are going to be under your a and your b. When I factor this, I get x minus 2, x plus 1, and I will go ahead, x minus 2, x plus 1. And I'll start this out by, I'll just kind of set my numerator. I know I tend to forget about it till the last thing, but I like to set it down right away. And then this is missing the x plus 1, so I'm going to multiply the a by that. And the b1 is missing the x minus 2. So I'm going to distribute those through. Ax plus a plus bx minus 2b. I will group my x's together. So I have ax plus bx and then plus a minus 2b. I'm going to factor out my x. and this is just my constant part. I can't do anything with that. So when I take a look at this, what's being multiplied to the x is a plus b, and what's being multiplied to the x over here is 2. So I'm going to set up my equation of a plus b must be equal to 2. And then this is my constant part. A minus 2b has to equal 5. So a minus 2b has to equal 5. And then I'll solve those however I wish to. I think I will change the top one all to negatives and then add them. So I have negative a minus b equals negative 2. A minus 2b equals 5. Whoa, that got crazy. So my a's eliminate, and I have a negative 1 minus 2, so I have a negative 3b. And that means 3. Oh, look at that. B is negative 1 again. And if b is negative 1, that means that a has to be 3. So I'm going to go ahead and put my a, my 3 right here, and my negative 1 right here. It would be nicer if I erased them. Okay. So this technically is my answer, the whole stinking thing. And it's very messy. And it looks Christmassy with the red and green. So, one more. Let's see. I keep adding more space in here. Okay, so this one, if we take a look at the denominator, I'm going to use the swing method. So I will take that 2 times that negative 3. So I have x squared minus 5x minus 6. And then I have x minus 6, x plus 1. And then I'll divide by my 2, because I have to bring that down. So I have, this one is going to be 2x plus 1, and this one's going to be x minus 3. All right, so x minus 3 goes under one of them, and it doesn't matter which one it goes under, because no matter how you do it, you'll get the right answer for your A and your right answer for B. 2x plus 1 here. Okay, I'm going to have to invest in new colors, I think. Ooh, I can get crazy colors. Can I? Oh, yes. Let's try purple. Okay, so this denominator is missing this. So I'm going to take A, and I'm going to multiply it by 2x plus 1. And my B, and multiply it by x minus 3. And I should have put my x plus 11 equals in here. Technically. All right, I'm going to distribute. So this looks fun, right? 2ax plus a plus bx minus 3b. Group my x's together. 2ax plus bx plus a minus 3b. I will take this and factor out an x. So I have x is 2a plus b. And then this is just my constant. There's nothing, no common factor in those. Okay, here's my x plus 11. So what I'm going to set equal to 1, because there's a 1 being multiplied to that x, is my 2a plus b. So 2a plus b is going to equal 1. And then my a minus 3b is going to equal my 11. All right, I think I will solve this just by, I don't know, let's just multiply the top by 3. So I have 6a plus 3b equals 3. Forgot to say, multiply that all by 3. And then I have my a minus 3b equals 11. Add those together, I have 7a equals, these cancel, 14. It looks like a equals 2. And if a equals 2, then I'm going to plug it into that first one. So 2 times 2 plus b equals 1 minus 4, b equals negative 3. So a equals 2, b equals negative 3. But to be fair, I need to plug them back in. So I will erase my a, erase my b, and I will put my 2 in for my a and my negative 3 in for my b. Ta-da! Well, this is already a 16-minute long video. I'm going to move on just a little bit to, and this is still day 1, but the improper rational expression.